don't want to disappoint you guys, but I don't have any piratins. There's a lot in the slides, so do watch out for them. But my presentation here is going to be about navigating in Compose Multiplatform. I kind of hid the title a little bit just to make it a little interesting. It's like a mystery box, what's going to be on this presentation. But I'm going to be talking about how to navigate in Compose Multiplatform. Can the guys in the back can me hear me fine? Yeah, all right. Okay, so my name is Isuru Rajapakse. I'm a senior Android developer at Motorola Solutions. We specialize in mobility solutions. We make apps for police officers, and hopefully it'll help them keeping the community safe. So that's the idea. All right, so that's enough about me. Let's talk about you. Who do we have here in the audience? Who actually have used Jetpack Compose? All right, we got the whole room full of people Jetpack Compose. That's awesome. All right, next question. Who's here using Compose Multiplatform? Oh, that's exciting. There's more people than I expected. That's all right. And who's here not using either of these technologies and find themselves extremely confused as to what I'm talking about? Okay, that's good. So let's actually define these terms. So let's have a quick terminology. Jetpack Compose. This is the Google's declarative UI toolkit. It's meant to make native Android UI. And what it gives you is a nice code-in DSL that lets you describe what you want and gives you UI, what you wanted. Pretty simple, right? It also has state management built right into it. So as developers, we only really need to define or declare the intended state, and the screens will compose themselves to achieve that desired state. And that's where the name comes from, by the way, I think. So what is Compose Multiplatform? Well, Compose Multiplatform is a fork of Jetpack Compose. It's managed by both Google and teams at JetBrains. It extends the same UI toolkit that you see for Android, but also now supports iOS, desktop, and also the web. I don't know why I emphasize desktop. Is there actually desktop developers here, by the way? All right, none. Okay, it's okay. All right, so at this point, you might be asking me, hey, what is this talk about? Well, let me set the stage for you guys. For Jetpack Compose, we have our own navigation library, a first-party navigation library, I should say, and it comes in the form of Android X navigation compose artifacts. This is the sort of go-to standards on most of the apps you'd see. However, on Compose Multiplatform, we don't really have a solution that is really first-party. We have a bunch of different options to use from. So that will be what's on the agenda. So we're going to go through different libraries and see what we like, see what we don't like, and see what we can use in production. Again, just to reiterate, first we're going to learn different problems of navigation, because we need to, I think, understand what we're trying to solve with the navigation library, and then actually see what libraries we have to solve those problems. We're not going to be using a library just because we want to. And we're going to go through a bunch of different libraries. I'll explain what these different libraries are in a bit, but that's going to be what's on the agenda. All right, now that we know what's going to be on the agenda, let's talk about what's not going to be on the agenda. We're not going to be talking about architecture. There was a whole talk just before this talk that talked about architecture testing. So we're going to skip that unit test altogether. As a team, you can use any of these architectures you want, if that's what you want. It's not navigation library's responsibility to tell you which architecture to use, right? Navigation is just navigation. You can use whatever architecture you want to use. As a team, you have to decide that yourselves. And number two, we're not going to be talking about dependency injection. Again, there's a whole different bunch of tools you could have used for this, and it's not the navigation library's responsibility to tell you what tool to use. All right, now it's time to get to the shape and learn about different problems. Now, if you're not using Jetpack Compose and you don't plan to, actually, are there any of those people here? Just curious, using just traditional views? Yeah. Even if you just plan to use traditional views for the foreseeable future, I think you should still join in. I think this is because essentially once you see what we're doing, it'll help you appreciate how Jetpack Compose makes it easier to streamline some of the navigation logic. If you are doing anything other than native Android development, I think you should still join in and see what kind of crazy stuff we're getting into. So this will be your glimpse at what native Android development looks like for you. All right, time to get into the shape. Now we're going to be looking at 5 different libraries. Fun count, is that 5? It's technically 6. First, we're going to start doing it ourselves without a navigation library. And then we're going to look at Android X navigation compose out of X. And then we're going to take a look at decompose and decompose router. And finally, we're going to take a look at the Voyager and circuit. So that's the plan. All right. Problem number 1. Stack navigation models, I think, is sort of the most common use case of a navigation library. This is where we push and pop screens from and to the user. So in order to visualize how this actually works, let's take a look at an example. In this example, we have 3 different screens. The 3 screens are what we call gangway, the deck, and the crow's nest on the top. So on the left, over here, what you would see is what the user would see. And on the right, over there, is a representation of what's happening in the memory. That card is the screen that you're looking at. Make sense? So when you push a screen, let's say the user tap on this arrow button on the top there. Actually, I forgot to mention, this is the root screen. We technically call this the root screen. When the user tap the arrow button, it essentially adds a new screen on top of the previous screen. So essentially, they are sandwiched or stacked on top of the previous screen. The previous screen still exists, but it's considered inactive or stopped, if you will. And then when the users navigate again, let's say if you go further up, the next screen is going to go on top of that. The previous screens are both stopped. And when users are going back to the previous screen, the new screen, the previous screen they were looking at, is now popped and then destroyed. I should note that the users don't really have to press that software back button. They can also press the physical back button on Android, right? And this is usually that comes in this format, I guess. I think right now it's just a gesture. And on web, we have a persistent back button at all times. You can actually go forward in web as well. And it doesn't really matter because we also have a URL. So you can just type whatever you want and go wherever you want in the app. All right, now that we know what we're trying to solve, let's just see how hard it is to do this ourselves. So here I have a simple Compose application. And here I'm using a simple enum class to represent different screens that I want to go to. So in this case, I have 3 screens. And in order to manage that stack that you previously saw, I'm just going to use a simple list. Just going to keep it simple. And when I want to go to a single slide, I have this slide composable. I don't want to get into how this actually works, but essentially you can think of it as a screen that has 2 different buttons in it. So when you want to go forward, what you do is you add your screen that you want to go to into the stack. And when you want to go backwards, just remove that screen from the stack. And that's it. That's all you need to do this screen, this simple screen with just yourself without any libraries. So it takes about 42 lines of code to do this for yourself, but let's actually have a quick review here. It is pretty nice and simple, right? It's not too much going on here. Again, we are just talking about static screens, so it doesn't really work well for complicated screens, but let's start simple, I guess. And number 2, you don't need a library. It's just pure Compose without any added libraries on top. The problem is there's no idea of a life cycle. And you'll see what this really means in a bit later, but there's no way to detect if a screen is being shown to the user or not. Let's take a look at the Android X navigation compose. Here, what you're doing is you are essentially creating a nav host controller. And you're feeding this nav host controller to a nav host. Here, we're defining what the initial root screen should look like. And in this case, I'm starting with the island. And in this case, you are defining the screens that you want to go to using a string. This is a little bit controversial, if you ask me. I don't want to get into the topic of why this is controversial, but the idea is that you're kind of forfeiting some of the type safety you would have get otherwise by defining a single string. There's a whole Reddit thread around people arguing about it. But I'm going to skip that for now. And in order to go forward, you just have to go to that string. And if you want to go backwards, you can just ask the navigator to just pop your backslash. And that's it. That's what Android X Navigation Compose gives you. Aside from the web like URL strings, it's not too bad, right? So let's have a quick review. It's nice and simple. Like it's pretty matching, similar to what we did ourselves with our navigation library. The strings route, the string-based routes are kind of icky, if you ask me. I like some type safety. I don't want to structure my app like a URL. And it's not multi-platform yet, I should say. All right, so let's take a look at another library. In this case, I'm going to use Decompose. So with Decompose, what you have to do is you have to define your screen configuration as a seal class. You don't have to, but in this case, I'm using the seal class. You'll see why this matters in a bit later. And then you have to create what you call a component. So Decompose is all about components. Components you can think of as an atomic unit that represents a single screen. In this component, I have a navigation stack, since I'm doing a stack navigation. And I'm also having a child stack to contain all my screens. And then you, in your UI side of things, you use the children composable function to hoist your components and show the different screens you want to show to the users. To navigate forward, you just push on top of that navigation on the component, and to navigate backwards, you just ask that navigation on the component to pop. Right. That's all it. That's all it. That's actually more code than before, if you noticed. You can actually judge that by the font size, if you will. So let's have a quick review. It is a little verbose, but I think the good thing about this is that this UI part that you're seeing here is completely pluggable, meaning that you can replace this with a different implementation of UI. So you can remove this, and if you want to use Swift UI, you can just plug that in with Swift UI. There is a lot of convenience extensions from Decompose themselves that lets you do this. And if you don't want to use Compose, let's say if you're doing Android Auto, and if you want to use those templates, you can still use that templates with Decompose. And it is very customizable, I should say. How customizable? Well, I actually made my own library just using Decompose itself, and I called it Decompose Router. So we can take a look at the Decompose Router right next. Again, Decompose Router, it's my own library. I'm leveraging the existing Decompose API to make my own API. So just like Decompose, we can create our own navigation sort of hierarchy with the configuration. In this case, I'm just calling it config, just keep it the same. And instead of creating components, you're not forced to create components in Decompose Router. Instead, you just create a router. In the router, you pass the initial screen you want to go to, and you can hoist your router inside of routed content. I'm sort of extending the same terminology from animated content, for instance. And then in order to navigate, you just push, and in order to go back, you just pop. And that's it. The actual code footprint of Compose Router is actually smaller. And it's actually, if you were to compare this side by side with our DIY solution, you'll see that they actually match one-to-one. So it's a pretty convenient way to do navigation with the navigation library itself. All right, so let's do a quick review here. It is nice and simple, right? It's pretty similar to the DIY solution. It is very familiar in the sense that you don't need to learn a whole different pattern just to use my library. And the number 3 is, I made it myself, so it must be the best thing ever. Right? I'm not biased at all. All right, so let's talk about a different library that has a different pattern. In this case, Voyager. The Voyager is a very popular library. I think it's the most popular, maybe. I don't know. I need to look at the GitHub stars if that's any metric. But the way it works is that on the root level, you define a navigator composable function where you pass in a screen. And when you're defining each of your screens, this is kind of icky, but you have to extend a base class or interface to implement a screen, which is kind of OP thing that we kind of tend to do on Compose. When you extend that, you get this composable function that you have to override, and this is where your content usually goes. In order to navigate, you have to hook into this static composition local called local navigator and get a navigator object from that. And then you can just ask a navigator to do pushing and popping as you usually do. And that's all for Voyager. It's actually not that bad, if you ask me. The only thing, yes, I think I've mentioned this before, but I'm going to do a quick refresher. It's easy to set up. It took like 5 minutes to set this up, fast to set it up. It's nice and simple, right? There's not too much happening here. The only thing I don't really like about it is how you have to extend or implement an interface. In Compose, we tend not to do inheritance hierarchies anymore because that was a way of the past with views. Here, instead, we just prefer functional composition instead of optical inheritance. All right, the next newest library in the block is Circuit, and this is from Slack. There was a talk about this on Quality Contrast here, which kind of got me interested. There's going to be a lot of code for Circuit, so I'm just going to quickly go through all of them. This is going to sound like a rap, but so you have to define a state even if you don't have a state. You also have to define events, even if you're just doing navigation between different screens. And you have to define a presenter, even if you don't have any business logic in your app, you still need a presenter to show screen. And you also have to declare your UI, which is fine because you're showing screens. And then we have to have a factory. Oh man, I haven't seen one of these in ages. So you have to define a factory to map your screens to, your presenters to your screen UI and your UI, your presenter. And once you do all that, you also have to actually hoist your configuration on a screen. Now, that was a lot of code to show these 3 screens between and have some navigation between them. I don't know, it's kind of too verbose for my taste. Let's actually see what's unique about it. It has this idea of a unique event seek, which is something that I haven't seen before. So instead of having the heavy machinery of coroutines to pipe events, they just have a simple lambda that's exposed by the state itself, which is unique, I should say. I might do that in our own architecture at some point. You're kind of locked into MVI. So if you're not a fan of doing events and state and have this whole MVI pattern implemented, this is not going to be your choice of library because you only can really do MVI, nothing but MVI. And it is also too verbose. I think we can technically solve it. Look at the font size here and see how verbose it is really. All right, now that we actually learned about stack navigation, let's take a look at another navigation model we have, and that is page or tab-based navigation. Here, you essentially have 3 different screens that users can go from and to. In this case, let's think about an example where we have a back deck, a middle deck, and a front deck. So the way that this navigation pattern works is that you have a single screen that is active in the middle or wherever, and the users can navigate to, let's say, left. And what this will do is will destroy the screen that is furthest away to allocate free up memory to new screens. So if it's not immediately right next to the screen that you're currently on, you expect that screen to be destroyed. When you go back to the middle screen, since we are right next to the active screen, we can recreate the screen. And when the users go right, it'll destroy the leftmost screen because it's furthest away. This navigation model is pretty commonly used in libraries like Conductor, for instance. The idea is that when you have so many pages of screens to show, we don't want to allocate screens unnecessarily if the user navigates to that. All right, let's see how we can do this ourselves. Similar to our own implementation, we have a single configuration in the enum class in this case. Instead of containing a list of stuff, I'm just going to contain a single item. Here, essentially, in my implementation, in order to navigate to a given screen, I just need to assign that configuration. I don't need to add or remove from a configuration list. Let's take a look at how Android X Navigation Compose does this. In this case, in order to navigate with Android X Navigation Compose, you have to define a special nav option that's called launch single top. What this will do is it'll keep only one of those instances at the given stack at all times. So essentially, they are retrofitting to make the stack work like a page on Android. In order to bring a page to the top, you just navigate to it and pass that single nav option into your navigation command. And that's it. In Decompose, the same pattern exists, and in this case, it's a different stack navigation implementation. So just like before, we have the same configurations, but the only difference here is that instead of assigning a stack navigation model, you just create a page navigation model, and it's implemented in the same way. In order to navigate, you can just do that. And instead of the child composable, you have the pages composable now. Voyager more or less works the same. Instead of extending a screen, now you extend a tab. So technically, you can also have a screen that extends a tab, that extends the screen, and have like a whole view hierarchy that doesn't really do anything, if that's your jam. The only thing I really like about, actually, something I kind of don't like about this is that you're kind of forced to provide tab options. So even if you don't plan on showing a tab layout, you still need to provide an icon and a label for it for whatever reason. And that's kind of icky, if you ask me. But everything else pretty much is the same. So far, we haven't really seen a good use case for a navigation library. Everything that you just saw, you can just implement that yourself. And if all you just really need is just a static screen, and you don't really need a navigation library at all. However, this is not really true for nested navigation models. To explain how this works, I need to bring up both examples from last time. So we have both a vertical, so a stack-based navigation model, and also a page-based navigation model where you can navigate between different screens. So in this example, here, assume you start with the gangway screen, you can go up into the deck, and here, animations frozen. Go up into the deck, and you can go left. And in this case, in the deck screen, you have a whole navigation hierarchy within it. So here you can go left. Say go left. There you go. You can go left, and it'll destroy the furthest away screen from you. And when you can also at this point go up the navigation hierarchy. So essentially, when you press the up button on top, it'll go onto the top, the crow's nest screen, which is a whole different screen. The thing to point out is that your previous navigation hierarchy is currently still there. So when you return back from this top screen, what is expected is that you go back to this previous screen the users were previously on, right? That's what the users would typically expect to happen, right? And when you go back, the previous configured screen is going to get destroyed as expected. And at this point, maybe I should ask this question from the audience. What's the expectation when you press the software or the hardware back button? Should you go back to the lower screen, or should you go back in the middle screen? It depends. Yeah. I think most of the implementations you see today, the current behavior is that it'll be consumed first by the nested screen, and then if there's no more nested screen to consume that back event, it'll then get passed back to the outermost parents. So if you do this on Navigation X Compose, for instance, it'll just change back to the middle screen. I'll save you some time without going into some code, but all of these libraries you saw have this behavior built in. The only thing that doesn't have it is my own library, sorry, do-it-yourself library. Circuit kind of has it. It's kind of optional API for whatever reason, but they're planning to make that required API. All right, the next thing, it's important, is animations. Who likes animations? Yes? I know people on Twitter says animations doesn't matter, but the mute button's right there. So let's talk about animations. In this case, I'm going to have the same screen layout. We're going to move from gangway to deck to crow's nest. Let's actually see how this looks like without any animations first, right? I know this frame rate on this meetup is pretty low, so it's as if you don't have any animations in the first place. But when you navigate without any animations, it's not just visually jarring, it can also be visually misleading, right? Because without any animations, the users kind of lose the context of where they actually are in the app. With animations, of course, you get this visual feedback telling the users, hey, this is where you are. So when you navigate back, the users know exactly where they are. This is a very subconscious thing, but it actually helps a lot in contextualizing where the users are. On web, we have a URL bar, address bar on the top, so it kind of helps with helping establish where you are. Sometimes web apps also have breadcrumbs to tell exactly where they are. But on Android and iOS, we don't have this. We don't have the space to show you. So that's something to be important. That's something to keep in mind. We do have to be very careful though, because if we use the wrong animations, like for instance, when the user try to go up and it starts sliding from the left, it's going to be jarring, right? And it's going to confuse the user more than if it wasn't there. There are a few different ways to do animations. Like these are the most common animations I've seen in most of the apps. You can slide or slide container, or you can just do a simple fade. It doesn't really matter. It's just taste. As long as something's there, it's okay. There's also Android-specific APIs, right? For instance, in Android 13 and Android 14, they will introduce this thing called the predictive back, where they can sort of glimpse at the previous screen without actually going to it. So you can figure out where you are. That's a platform-specific APIs you need to keep in mind. You can do this yourself if you really want to. Again, this comes at the cost of having no lifecycle associated with it. All you really need to do is to wrap your whole composable in an animated content, and then you can animate whatever screens you want to your heart's content. With Android X Navigation Compose, you have a bunch of overloaded methods, pop and exit transitions and enter transitions you can specify. With Decompose, you have a similar overloaded method, which provides you with animation API, which is similar to the foundation APIs. Decompose also provides support for predictive back animations. So off the shelf, you can actually use that and have predictive back animations, not just on Android, also on iOS. Voyager's implementation of the navigator kind of looks weird. The transition looks weird. So instead of passing a parameter, it's a composable function you have to wrap around your existing composable function, which it's kind of weird, but that's how they implement that. The next one I'm going to talk about is Circuit. Has its own navigation animations as well. They're calling it slide decorations for whatever reason. I don't know. It's like a recyclable decorator, but just for animations. I don't know, weird wording. And that's how we do. Circuit also supports predictive back animations as well. All right, now that we know how to animate screens, the next problem we want to solve is how to pass data between screens. Now, this is the most common use case of a navigation library. Let's actually talk about an example screen. So here we have two screens. You can actually think of this as a list screen and a detail screen. Here in the ship screen, we have a list of items the users can select. And on the detail screens, they can crack open the boxes and show you the details. And in the list screen, essentially the users can make selection, which get passed down to the detail screen as an argument. So let's visualize this in how this actually works in the memory. In the root, we have this list screen, and the users have to scroll on this long ladder to grab the one item they want from the shelf. And they go to that item and say, I want that one. And it'll get populated in the next detail screen as well. In this case, in the detail screen, they can show that argument. These arguments are meant to be immutable, by the way, because if they select a different argument, we need to be able to swap that argument around and show a different screen to them. Once the new argument is shown, they can go to the detail screen and show that to the screen. That's it. That's what we want to implement. Let's actually see. Actually, before we get into that, when you press the back button, right, the expected interaction is that you're supposed to go back to the top of the list where the users were, right? If you are back stuck on the bottom of the list, it's going to be a very bad experience to the user, right? Because the user now has to start scrolling again to get to that one item they want. And when you go back, the list screen is going to be different. So in this case, if they make a different selection, we need to populate a new screen that shows that new item. Okay, so let's see how we can implement this ourselves. Implementing this ourselves isn't really that hard either. So instead of a normal enum or a data object, we just use a data class. And in this case, the data class it's immutable by itself. So you don't have to worry about how the arguments are different. In this case, then you can just pass that argument and check the type, and then let the Kotlin Smart task take you all the way through. Navigating with Android X navigation compose with arguments is kind of like hell, because you not only need to check for argument types, you also have to like create this URL string that kind of looks like a web browser thingy, and it's not. I don't know why we're doing it, because in Android we don't have a URL and address on the top, so that's kind of weird. But anyways, we have to check for the URL on the route, and then we also need to manually serialize those values one by one, and then we want to consume that value. We just need to manually deserialize that value as well. There's a lot of code to just pass one argument around, so I don't know, just makes me tired. I'm going to save some time. All of these libraries actually have type safe navigation arguments. So if that's something you really want, you can use any of these libraries and it will work as expected. And the final problem that I want to solve today is about scoping instances. I might take some little bit more time to explain how this actually makes sense. So let's talk about scoping instances. In order to explain how this works, I need two different screens. And more importantly, I need a screen that has changing state over time. In this case, we're going to be finding this cannonball, and that has some state that will change over time. And we're going to have some other screen that has some effect, and it will also change over time. So in this case, we have an initial screen, the ship screen, and it will have an initial argument set to it. So we'll be passing in number 6, and that will be the number of cannonballs we start off with. And when you have perform an action, since we can't really change this argument, right, we need to modify the number of arguments we have. So in this case, we're going to fire off a cannonball, and that's going to change the number of cannonballs from 6 to 5. And what's going to happen is that even though this looks like a nice place to put your state in, the problem is on Android, your screen's configurations can change, and it's going to destroy your state. It's going to wipe your state back to where it was, in this case 6, and user is going to be confused as to what happened. To get around this, what we need to do is to take this, we need to take this state out of the screen and put it in some sort of an instance. The thing about this instance is that once we contain this in the state within the instance, it can outlive our screen configuration. So when the state does change, let's say if you fire off another cannonball, it still can update that state in that instance. And then when the views eventually get destroyed, let's say users rotate their device once again, it's not going to lose that state anymore, right? That's the whole point of having state in that instance. The reason why we are scoping this to this given screen is that we don't want to have free-floating instances in the app. It's going to leak a bunch of memory for you. I've been careful and I've been using the word instance a lot, but this is because I didn't want to talk about architecture. This instance might as well be a viewpoint, a presenter, a domain, or whatever you want to call it. The idea is that we want this instance to hold state for us. Essentially, it acts as a state holder. When the users navigate to a screen, it could also have its own state. Like in this case, the ship screen has its damage number. So when it takes more damage, it's going to change its UI to reflect that. But the thing importantly is that when the users navigate or do a screen configuration change, for instance, it's also going to change both the UI, and when the users go back, it's going to not only destroy that screen, it's also going to destroy that instance associated with that screen. Let's quickly take a quick look at how Android X does this. Android X simply has a nice Android architecture view model extension function called view model. As long as you're using the ACV model, you can just call the extension function and expect your screens to be scoped, your instances to be scoped with these screens. If you have a changing argument, you can just pass that to the lambda. In Decompose, all the components are by default scoped to the screens that you're looking at. So we don't need to manually pass anything. With Decompose router, though, because since we don't have components in Decompose router, I have this convenient extension function called remember on route. So what this will do is will remember those instances on the route as long as that screen is in the backstack. And again, I named it like this because I want to be architecture agnostic. And just to save more time, all the libraries that you've seen so far has that architecture, has the scoped instances going on. So you don't need to worry about any of these libraries. And that's it. We've learned all the different challenges in navigation. We started with stack, pages, and talked about some animations and how we can implement nested screens. And then finally, we talked about how we can pass arguments back and forth, and then how we can scope your instances to given string. And we also learned about how different libraries we have used from, and including Android X navigation libraries, Decompose, Voyager, and in this case, you also made your own navigation library just by looking at it. And thanks for listening. And I also want to thank Motorola Solutions for empowering my presentation. And also thanks for Academy for reviewing my talk. Thanks, everyone.